Alright, let's play around with GUIs. So I'm running Eclipse on my own system. We don't want to do GUI development on the Linux server because if we set up an external, it'll work, but it's really, really slow. So you want to be running Eclipse on your own system. Ideally a Linux system, but if you do this in Windows, it will probably work. But, you know, don't leave things to the last minute, and if problems come up, we can work through them during class and such. So I've got Eclipse running right now. I'm going to say File, New, and I'm going to do a new Java project. And I'm just going to call it Class 11 New Demo. And I'm going to right-click on here and say New, and instead of saying a new class, I'm going to come down to Other. And if it's not already selected, I'm going to select Window Builder, and then Swing Designer. And then I'm going to say new JFrame, and I'll say next, and I'm just going to put in the name of the JFrame that I want. So I'm just going to call it mainframe, and that's all I need. So this creates a chunk of code for me that basically, you know, declares that I'm making a new class called mainframe, but it says it extends a JFrame. So what's a JFrame? JFrame is a class that's available to us. And we can pull up, you know, Java documentation on it. And it's basically a container. It's an empty, you know, rectangular window in which we can place other graphical elements. And it comes, you know, with a slew of methods available, but it also inherits a lot of methods from other classes that it extends. So all of these methods, these functions are available inside a JFrame. So if I run this code as is, I just get a little window that pops up. I can move it around, I can resize it, I can close it. That's all it does, right? But we can do a lot of experimentation and work just with that simple element. So we're not going to worry too much about the code right now. We'll dig further into this as we begin to develop more, but we can see a few things in here. For example, it says set bounds. Well, this controls the dimensions of the frame, and if I change this 450 to, you know, like 1450, and I run this, I get a much wider window, right? So this is the X dimension of my window, this is the Y dimension. And if I go back to that documentation on the JFrame, I can see there's a method called well, what's the method called? Set bounds. So I can look for set bounds, and that's a method inherited from Windows, and it lets me set XY coordinates for the window and then a width and a height. So if I change this to be you know, 400 comma 400, and then I run this, my window appears down here. If I change it to be 40 and 40, that's the X and Y coordinates of my window, it's going to appear up here, right? So we can modify the behavior of this JFrame by making changes to the code, but there's a generally better way to do that, and that's by clicking on this Design tab. This is what Window Builder provides for us. And this will bring up a graphical display of our window. And so now, for example, if I take this and I say, you know, let's make this window really big, well, when I run it, I get, you know, a really big window. And how does that work? Well, when I change the size of this window, it changes the code. It says, okay, let's make this 926 by 578. If I make this window much smaller, so something like that, and I look at my source code, it's only 222 by 119. So we can use this Design tab to graphically manipulate our visual elements, and we can do a number of things like this. So for example, on this JFrame, right, this mainframe, I can find something called title, and I can type a title for my window here. Now I seem to have a bug in my installation of Eclipse. Bugs are not terribly common, but they do happen. So I'm just going to call this Nix window, and while I'm typing, nothing is appearing in here. but if I click away, we'll see that it actually did, set my text to that. And if you think you're typing and nothing is happening, you can Control A to see what you've typed, and retype and have confidence. All right, so there's Nick's window. And when the window gets closed, it's set to exit, but I can also change it to do other things when I close the window, such as do nothing. But right now, when we run this, if we close the window by hitting this little X, it says that the whole program terminated. All right, so this is a J-frame. That's the holder for other components. This component inside is called a content pane, and it's mostly a content pane that we're going to place components into. So what is a content pane? It's called a JPanel, and we can look at the documentation for a JPanel, and it's just another class. It's an extension of a component, container, component, and object, and content panes. JPanels have all of these methods available. All right, so let's put some things into this frame. Now, normally when you design a graphical window, we don't place components at particular locations. We place components relative to one another or relative to the edges, so that, for example, if you write something for a large laptop and then somebody runs it on a small phone or a watch, you don't have buttons disappearing off the edge and so on. But we don't want that, right? We're just designing GUIs that we're going to develop on a computer, run on a computer, and we want complete control over where things are placed. So the first thing we're going to do is click over here under Layouts, Absolute Layout. I'm going to click and release, bring my mouse in here, and I'll see that I have a green box highlighted around my content pane and a little plus sign. I'm just going to left click and release. And when I do that, it creates a line of code which says content pane.set layout null. And that's the way of saying whenever I place something in here, that's where I want it to stay. So now we can take some of these components and we can start placing them into our box. So I'm going to take this J label and place it right here. And if I don't want that, I can click on it to select it, and I can hit my delete button and it goes away. And I can take a J label and place it over here, and I can take another J label and place it over here. So now I've got a J frame with a J panel inside and two labels, and if I run this, that's exactly what I get. And those labels will not move. If they fall off the edge, they disappear or get truncated and so on. That's fine. That's exactly what we want. Now, each of these things that we create, labels, for example, have a lot of properties we can set. For example, I can change the text. Right now, the text is new label, but I'm going to change this and call it first label. And I can resize it right here if I want. And remember, everything that I'm doing here is changing code. So there's code that says create a new J label called label new label and set the title to first label and set the bounds, the dimensions and location to this. And then this second label, I'm going to just change that to say info with a typo. So let me info. And we can spend a lot of time playing with a lot of different things. For example, I can click on background, and these little dots expand your selection options. So I can click on that, and I can say, let's select a color, and let's make the background a minty green, and say OK. And so something looks wrong here, right? Because we said to make the background minty green, but it's not happening. There are a lot of things like this that will pop up when you're playing around with Swing, where it looks like a malfunction, but it's not. So this does take some Googling, but be careful with Googling. Don't go down deep rabbit holes, right? Most of what you need to know will come out in the videos or when we talk during practice problems and so on. But here's an example of something where, setting the background should make the background green, but it doesn't. Well, it turns out that there's a property of labels called opaqueness. And so if we look at documentation on a J label, and we look at the background method, set background, sets the background color of this component. The background color is only used if the component is opaque. All right, well, what does that mean? The component has to be set to be non-see-through. So if we just, search for opaque on this page, there's an isOpaque method that tells us whether it's opaque or not. And there's a set opaque. It takes a Boolean and tells us whether or not we can see through this component. So this little arrow up here in the properties box that shows advanced properties, if I click on that and I come down here and look at opaque, I can see opaque is false. So I'm going to click that to make it true, and now we've got a background. And again, we can go back to our code, and now we see more code around this label, including a call to the setOpaque method that says make this label opaque. All right, so we're working with some really, really powerful classes, lots of methods, lots of fields, right, associated with properties, and we need to be aware of this level of complexity, because sometimes things that look like they should work one way don't work that way, or work a different way. And so you want to get in the habit of writing test code, right? When you've got a large programming assignment, like we're going to make a tic-tac-toe game maybe, don't just start off and let that be your introduction to swing, right? Write little programs like this, try to place things down. If you want to make a button that responds to a click, write a program that just places a button and tries to respond to a click. Don't try to do that while you're developing a much larger piece of code. All right, so let's try a button, right? Let's take a J button and drop it in here. And by default, it highlights the text. And so we can just type, click this button. And I can make this bigger so that we can read the text. And I can move this around wherever I want. And if we run this, we've got a label, we got a green label, and we've got to click this button. We can click it, we can hit the space bar if it's selected and click it, but it doesn't do anything. So easiest way to tie an action to this, double click the button and it will write some more code for you. In this case, it's adding what's called an action listener, and it's writing a method called action performed. This piece of code, this method, is going to get called whenever the button is clicked. So let's put a print method in here. And we'll just say button was clicked. And let's run this. And now every time I click the button, I get a message in my console saying button was clicked. All right, and now we're off and running, right? So we could do things like this. Let's go up here and let's put a click counter in here. And every time the button is clicked, let's print out that current click count. And let's keep track of the number of clicks. And now when I run this, each time I click it, it tells me button was clicked 1, 2, 3, 4, 5, 6, 7, and so on. All right, so we can interact with graphical elements by having code that runs in response to the event. And at this point, if we look at our main program, what does our main program do? It creates a new mainframe. Remember, mainframe is the name we gave to our JFrame when we created it. It calls the setVisible method, which makes it, appear. And this is inside a try block. Here's the catch block. And this is all in a method called run, right? And that's all the main method does, right? It doesn't go into a loop and wait for the button to be clicked. It doesn't constantly update the display. It basically goes to sleep. But before going to sleep, it sets things up like an action listener. And inside Java, when a button is clicked, the system will look for action listeners that have said, hey, I want to be told when this button is clicked. And in this case, it will find that this function, this method action perform, should be called, and it'll go ahead and call it. And these methods get called with arguments, and so we could print out what this argument e looks like. Right, that's an argument to this method. So if we run this and we click the button, e is an action event, and it's got a bunch of different pieces to it. Command equals click this button. Well, that's the title of the button. When equals, that's some kind of timestamp. Modifiers equals button 1. Well, if I right click, nothing happens. But if I left click while holding the control button, it says modifiers equals control plus button 1. Or I can do shift plus button 1, or control shift, or control shift alt plus button 1, and so on. And so there's a lot of information available in this object, this action event object that's passed to us. And what is an action event? It's just another class. And it has a variety of fields available to us, including, a mask that tells us if the alt button was pressed or the control button was pressed, and some methods available, and so on. All right. What about these labels? So we had documentation on a J label. If we look for text in our description, right, a display area for a short text string, and the method is called setText. But if you don't know that, you can, just search everywhere that the word text appears. And eventually we see, there's a method called getText, and there's a method called setText right there. Right, which defines a single line of text displayed on the component. So what I could do in here is when the button is clicked, I could say, let's change the label on this info label. So what's this info label called? Label new label _1. Well, that's an annoying name for a label, but that's okay. Let's do label new label 1.setText. And let's just change the label to say click. So here's our window. When I click the button, this label changes and now it says click. And if I don't like that name, label J label 1, I can come up here under variable and I can say, let's call this info label. And now if I look in my source code, it's called info label, right? It's declared up here as info label. It uses that, and it changed my code when I said setText to use info label. And so this is important lesson to keep in mind. The design window and the source window have to live in harmony with each other. And you can make changes to the code over here, but you've got to be a little careful. If I were to totally make large-scale changes to this, and then go back to the design window, I might get an error saying, hey, I don't know what this design window should look like anymore, because this source code is being written by Window Builder. So you gotta be a little careful when you start making changes, and it's not a bad idea if you're thinking of making large-scale changes, keep going back to your design tab, make sure it still works. All right, so we can change properties in code, we can change fields in code, and so on and so forth. And we can tie events into our code. So let's look at a text field. So I'll put a text field in here, and it's just called text field. That's not a bad name. And I'll say type stuff. And we want to run some code when the person types in this box. Okay, so I'm going to right click in here and I'm going to say add event handler, and I'm going to add something. I can type something here for key pressed or key released or key typed. So pressed is when you push down a key, released is when you let it go. Typed is when you've done both, when you've actually typed a character in here. So let me click on key typed, and in here we've got, you know, another listener. It's a key listener, and there's a method called key typed. It's passed an event E. So let me just put a print message in here. And let's just say we're inside key typed, and let's print out the value of E. So we'll run this, and we'll come in here in this type stuff box, and I'll hit a letter, and it says, hey, we're inside key typed, and here's what this object E looks like. Well, there's a thing called key character, which is an A. There's also a key code, which is a 0. If I type a B, it says key character equals B. If I type a shift A, it says key character equals big A, and modifier is shift. So we can get a lot of information from our listener that's being called when an event occurs. So let's take a look at what a key event is. So we'll pull up documentation on a key event. And it's got some static fields identified for the different characters that we can type, and a few other properties. And then it's got some methods like get key character, which returns a character, get key code, which returns an integer associated with the key, get key text. That's a static method. So let's get the key code. So e.get key. Let's get the key code and see what that looks like. So I'll come in here, I'll type in A, it's a 0, B is a 0. So that's not terribly insightful. That's a little weird. Let's get the key character. So here's A, B, C, D, E, F, G, 1, 2, 3. There's an enter key. There's a question mark, and so on. So I guess I don't know what a key code should be returning, but key character returns, you know, the actual character that we see. The integer code for an actual key on the keyboard. That only works for when you have key pressed or key released. For key typed events, the key code is undefined, which is a 0. But if I were to add an event handler key for key pressed, and let's print the key code here. So inside key pressed, let's see what the key code is. So I type an A and it says key code is 65. Type a B, it's 66. I type a space, it's 32. So those look like ASCII codes. When I hit a shift key, it's a 16. When I hit shift key followed by an A, the key code is 65, but it was preceded by a key code 16, which meant shift, right? And a lowercase a should not be a key code of 65, right? It should be like 97. So this is a way to sort of figure out exactly which keys are being pressed, instead of just seeing the actual character. So that's a control, and that's the Alt key, and that's the Windows key, which brought up a key code 524 followed by a 17, and also, you know, popped up something else on my desktop. All right, so we can set up events for all of these different kinds of things. So let's look at this button. Let's right click and add an event handler. And action performed means, you know, what do we do when the button gets clicked? But we can also say what happens when it gains or loses focus. Or we can say what happens when the mouse enters or leaves this area. So we can say mouse entered. And let's just print a message here. And we'll just say mouse entered the button. And if I run this, when I get my mouse over the button, it says mouse entered. Now I'm not clicking, right? I'm just moving my mouse. So this is very fine-grained, right? We can get information about lots of events, things that we don't normally think of as generating events, like, you know, putting the mouse pointer over a button, even though we're not clicking. And in this J panel, we can add an event handler, and let's add a mouse motion, and we'll do a mouse moved, and let's print a message inside here. All right. JPanel, add event handler, mouse motion, mouse moved. So we'll just say mouse is moving. And if we run this, every time that my mouse moves over this panel, I get a message. Now when I move it over the button or over my text field, it does not respond, but when I move it over the panel, it does. Well, mouse motion is called with a mouse event. And if I look at the documentation for a mouse event, it has some methods available, including getX and getY, which return the XY positions of the mouse. So let's embellish this message. So E is the mouse event, so we can say E.getX, and then we'll print a comma, and then we'll print E.getY, and then we'll print out a closing parenthesis. So we'll print out mouse's moving location equals, and we'll print out the XY location in parentheses. And so when I run this, we can see up here, we're sitting pretty close to 0, 0, right? And the upper left corner is probably 0, 0. And then down here, you know, we increase X going across, we increase Y going down. And so we can pick up, you know, what's happening to the mouse as it moves around in this J panel. All right, so a lot of information available. And on top of all of that, right, remember we have, you know, Java available to us. So for example, when I said click this button, let me just double click to come back in here. We said button was clicked and we could print out a click count, right? Well, to do that, all we had to do was, you know, declare a variable, and then in our code increment it each time it gets clicked and print that out. And so we can you know, write code to respond to events in different ways, to do pretty much anything that we want. All right. So for practice problems today, you're going to mess around with various events, and there's a lot of things. If you pick any object like a J-frame You can right click, look at event handlers, and there's a lot of things you can do. For example, we could look at the window and see what happens when the window is opened or closed, or iconified, when the window gains or loses focus, when the window state changes. We can look at the component and see what happens when the component is resized, right? So a J-frame is a component. And if we write some code that responds to a resize event, that method will be passed an argument that will contain information such as, why we're in that method. And we'll be able to figure out the new window size and so on and so forth. So you're going to play around with a lot of that stuff. But this is the basic setup, right? And we do a little bit of writing in code, but, we certainly did not type 105 lines of code today. Most of this was created for us by Window Builder, and we're just writing a few pieces of code, mostly for event handlers, and that's going to be a pattern that we repeat throughout. All right, so on top of this, we can start doing graphics to make things appear, to draw lines and things like that. But for that, we're going to have to go back and revisit extensions in a deeper way. So that's going to be the topic of our next video.